Hello, Latency. Here today we're going to talk about how to sec your DevOps, and we're going to dive straight in with a few quick questions. Who here is involved in delivering software? Most of you, excellent. And put your hand up if you're confident that your testing practices result in the delivery of quality software. Yeah, not too bad. And keep that hand up if you're confident that your security practices result in the delivery of secure software. Yeah, that last one just feels so much more awkward, doesn't it? And strangely, I think we all know why, but I can best explain with a story. About 15 years ago, in a dev team just over in West Perth, a group of young engineers was getting their latest set of features ready for prod. And they punted the set over to the test team to go get tested. And there was a lot of business requirements and functionality, and so to get a handle on all this, we turned to an industry standard tool to build a grand unified testing manual, Microsoft Word. And the testing was soon done, and it was time to take the stuff to prod. And again, there was complexity. There was multiple services to take offline, databases to upgrade, assemblies to copy across. And so we built a great big script in Microsoft Word. And of course, these days we stream our changes into prod with our CI/CD pipelines, and we get telemetry and insights back to the engineers that built that system in the first place. But eventually, someone walks around and asks, what about security? And so we call in some consultants to do a pen test. And we wait patiently for them to give us a report in Microsoft Word. And yes, the knee-jerk reaction is we have to shift left and automate, and for the most part, that's right. But the sort of controls and techniques we'll talk about today, they fit in throughout your DevOps lifecycle, and rightly so. Some of them, if they're too far left, they can be skipped and bypassed, and others only make sense if you're recovering from an active attack or trying to defend something that's happening right now. But before we dive into the tools, I want to talk a little bit about culture. And readers of Freakonomics may be familiar with a study done on daycare, where parents are picking up their kids too late. So the economists theorized, let's just charge a fine every time this happens. $3 per child every time you pick up your kid late. And I'm not suggesting you should start fining your developers if they ship security vulnerabilities to prod, but you can understand the connection between creating a disincentive for bad behavior. But strangely, what happened is the rate of late pickups increased because that fine turned into a fee for service and allowed parents to avoid accountability and responsibility. And that's quite interesting as developers in our pursuit for shared accountability. When I had the title security manager added to my title, people started asking me to approve things just organically out of the blue. And that was useful at first, so I got some extra insight on what was happening on in the business. But eventually I started getting requests like, oh, look, we think it's kind of awful, but we want to turn off authorization in prod. But Ted said maybe if we checked with you, it would be okay. And so I'd become the fee for service that allowed others to avoid accountability. You want to be really careful about creating any kind of sign-off process, and you may even have to actively deconstruct sign-off processes that emerge in your business. You need to share that accountability with your whole team, make sure everyone feels confident and capable, so a bit of upskilling and learning will help as well. The economists did theorize that potentially if the penalty was high enough, you could get the desired outcome. So I don't know, maybe next time there's a bug in prod, you could just walk out and execute an engineer. But I think then you have the next problem, right? Like, is it more important to pay down some tech debt or to fix a bug? What about building a shiny new feature or paying down that tech debt? Who's been in sprint planning trying to decide between the shiny feature from marketing or the scary vulnerability from InfoSec? Both sides would have shrill opinions, and probably rightly so. But you're never going to get alignment between all your teams and between all your key stakeholders without addressing three things. The first, you need to define your threat model. And threat model is a broad subject, broad enough for an entire talk on its own, but roughly you need to understand the ways in which your application can fail and your tolerance for those failures. For example, if your application only ever deals with public source data and only ever emits public source data, you probably don't care about a data breach. But then also you need to talk to the wider business and understand what the business's risk appetite is. How willing are they to take a bit of a gamble to push things forward? With that information, you can sort of build a philosophy around vulnerability remediation. And I understand, for example, though don't quote me, that Atlassian's approach is to prioritize performance and security over new features. But your organization may very well differ. Lastly, you need to understand the impact of a particular vulnerability and how that fits into your threat model. And then when you have all three pieces together, then you can your team knows how to focus their efforts on the right way forward. And speaking of focus, here's a photo I snapped of an ophthalmologist a few months ago. I was left alone in the sort of surgery waiting for the surgeon to arrive, and there was an unlocked Windows desktop PC with screenfuls of medical data on it and a password on the post-it. And I was sitting there trying to digest this, and then a nurse came in and unlocked a second machine on my left, and then left the room. And I was there for about 10 minutes. So I immediately snapped a photo with my phone to share with my mates, and then had this strange sense of déjà vu. Mocking and sort of calling out these bad implementations is a really common pastime for software engineers. And I think I understand why it's so seductive, right? We spend a lot of time honing our skills and mastering our craft, and so when we identify something that's wrong, it gives us self-affirmation. But it's a slippery slope. We often leap too quickly to criticize and say, no, that's wrong, rather than pausing to understand why and sharing this as how. We can, over time, mature and sort of see these as moments not to stomp on the psychological safety of our team, but instead uplift everyone around us. In the ophthalmology example, the surgeon's time is highly valuable, and they simply evolved a process to maximize that valuable time of the surgeon. And without addressing that underlying behavior, no amount of security awareness training is going to change what's happening in that place. So, now time to burn some social capital and make some enemies. Kubernetes security is a myth. Bold claims require bold evidence, right? Well, there are at least 2 conferences where the entire course track is dedicated to trying to get a handle on Kubernetes security. And look, obviously that's a little tongue-in-cheek, but my point is that the level of abstraction you choose to work with when designing and building a system directly impacts how hard it is to secure it. OS patching, for example, is a relatively solved problem, but doesn't happen by default on a running container. Think about your most stable, long-running, barely touched running container. When was the last time you deployed it? And did you rebuild from an updated base image at the time? The whole process is even more complex if the base image has been provided by a third party. If instead you had chosen perhaps functions as a service-based architecture, this issue doesn't exist at all. And the unfortunate reality is that over time, systems degrade. And I don't mean in the abstract sense, like a depreciating asset on a CTO's balance sheet, but quite literally that the systems that you don't actively maintain drift away from where they need to be. Your major frameworks shift and drift, your third-party library versions shift and drift, and the improvements in architecture and practices that you develop and nurture in other teams often don't get back propagated to those dormant systems. What can happen is a simple third-party vulnerability and like a third-party library, which should be just a simple platform upgrade or library upgrade, can turn into this high-pressure, high-intensity, major framework versions across multiple applications to get it into prod again. And you want to essentially keep an inventory of all of your running systems, your libraries and your major frameworks in use, set some tolerances and benchmarks of where you want to keep to, and then monitor and track that over time. Another thing we often like to set and forget is our build pipelines. And it's totally cool and totally normal to consume a third-party open source package from a public feed and a private package from a private package feed. But what happens if someone uploads a malicious package to the public feed with a name that conflicts with your private feed? Well, a security researcher called Alex Bursan discovered back in February of this year that it's often quite trivial to make the package manager prefer that public package. And what makes this worse is that when the package gets installed by the package manager, it can execute arbitrary code. And even worse still is when we think about where that's executing. in the middle of our build pipeline, potentially has access to our production environments or production keys and secrets. And to address this, you don't simply upgrade your package manager to the latest version. The actual fix depends according to the package manager you use, but generally involves something like reserving a package name prefix, like company name dot, and then renaming all of your packages to make sure they meet that convention. And so those secrets we were dealing with before, they're the keys to the castle, right? We want to make sure we look after them. And there's a few different ways we can do that. But keeping secrets in your code base sucks, and we sort of implicitly acknowledge that. It's inflexible, and although a leak of your code base is pretty catastrophic, it shouldn't also mean that your production environments are immediately owned. Secrets in config is a bit better, and now we can do some segmentation, right? If someone smashes your dev environment, they haven't also smashed your prod environment. And it also helps to minimize accidentally sending test data to your production customers. But where we're seeing some really good opportunities now is using a proper secret manager, something like HashiCorp Vault or Azure Key Vault. And here you've got a proper managed service giving you a full audit trail of how your secrets have been accessed by other systems and applications. And some of them are even offering honeypot secrets, where if anything is sort of accessed unusually and suspiciously, you can get a security alert fired from that. But to truly transcend the problem, you want to have no secrets at all. And many of the major cloud platform providers these days allow you to access the intrinsic service identity of your running application and assign permissions and privileges and roles to that to access other services. And in doing so, this means you no longer have passwords in your connection strings for your databases or API keys for accessing your internal APIs. And again, the technology differs according to the platforms. In Azure, you're talking about managed identity. AWS has the concept of execution roles for running Lambdas, and GCP has a function identity for a running function. But to make sure your team always takes the Galaxy Brain approach requires some training and education. And there's a few things at Cashies that have been effective for us so far. Firstly, we've changed the way we do our pen tester engagements. It used to be sort of a see you in 1 week and we'd come back and check what they found. And these days we drop them in a chat with the rest of our engineering team. And when suspected vulnerabilities are found, we chase them down together collaboratively. We're continuing to build out our guides and reference implementations, so both in code and sort of wiki formats. And we started running some wargaming sessions where we set aside an entire day and the engineering team explores the kind of suspected vulnerabilities they have in even like high-level logical errors in our application, and tests our existing controls to see if they're effective or not. And lastly, we've been playing a little bit with some of the security training vendors. They can be quite expensive or have kind of arbitrarily irrational minimum seat counts. But what we have found is they often run promotional exercises with conferences where you can kind of access a free tournament for 2 or 3 days and free training. And they've been quite good for getting our team in there and playing with some vulnerability hunting. But word of warning, the only thing thirstier than a software recruiter on LinkedIn is a security vendor. And so now our team, they're skilled. We want to let them fly, be free, and run around. And give them some guardrails though, right, to avoid the common pitfalls. And a great way to do this is to use policy on your infrastructure as code. So policy lets you do things like identify things like a public storage account or a web API that doesn't have TLS configuration, and forbid that from ever making its way into your cloud environment. It can be enforced either statically during your build pipeline or at the time of deployment. HashiCorp has Terraform Sentinel, which does this sort of thing, and in Azure, we've been using Azure Policy. And so now we're finally at the tools proper. And the good news is, most of your existing tool chain is going to pay heaps of dividends here. I think you can unironically use the word synergy, but essentially your application performance monitoring and telemetry and anomaly detection is going to work just as well for detecting security anomalies as it is application anomalies. You might have to tweak some dashboards and queries, but for the most part, it's all still there. Your infrastructure as code and your ephemeral deployments or your ephemeral environments mean recovery from a major compromise is much easier. You can just blow it all away and re-provision it. And your CI/CD pipelines and your short, tight cycle times mean you can rapidly ship vulnerabilities out to prod. But there are some shiny new acronyms, and has anyone noticed that all the security folks have like the cool acronyms and like phrases like RASP and OWASP and the cyber kill chain and Z attack proxy, and then over in engineering we're all dog fooding dry solid crud? Anyway, these tools, there's so many of them. I'm only going to talk about them at a family and sort of intent level, and they fit at various points along your journey from IDE to production. Starting off is static analysis. And within static analysis or static application security testing is software composition analysis. And this tries to deal with the fact that modern applications are composed of a lot of third-party libraries, and many of those may have vulnerabilities in them. Keeping track of which of those are vulnerable and which ones you need to patch is where this tool comes in. Similarly, you probably care about which license is being used by your third-party libraries. If you're grabbing something in that's got a strong copyleft license, you probably want to avoid having that open sourcing obligation on your own internal code base. And yeah, again, there's so many tools in this space. I'm just listing a few random ones at the bottom. Commercial ones tend to be very good against multiple frameworks and different languages and that sort of thing. If you've got a very diverse environment, the commercial ones can give you a lot of coverage of those, whereas the open source ones can be a bit more narrow in focus and require a bit more glue to kind of tie into a CI/CD pipeline. The next part of static analysis is secret scanning. So we talked earlier about how the secrets in code really suck. This is how you find them if they've leaked past your frontline defenses. And so these tools look for secrets not just in the head of your repository, but even in historical commits. And we'll cover things like your API keys to production third-party services, to things like your Azure account management key. And lastly, we've got static analysis, or vulnerability scanning in static analysis. And here, it's interesting. I find that generally the false positive rate makes these hard to integrate into a CI/CD pipeline. But I've had a lot more success using IDE plugins where you can kind of sift through the noise a lot easier inside an IDE. For anyone who did Derek's awesome workshop yesterday on securing your DevOps, Sonar Cube, I believe, was the static analysis tool you used there. Sonar Lint's a sibling version of that's available in your IDE. And now interactive application security testing is like the cooler cousin of static analysis. And here we grab a runtime component similar to like New Relic or Stackify, and you embed it in your running application to get security telemetry. You wear a performance penalty, so you can't do it in prod, but it is fairly well suited if you have a manual QA process still, where you can let your existing use of your application generate information you can use for security review. Similarly, if you've got an existing automated integration test pipeline, you can supplement that with additional information. Much lower false positive rate than classic static analysis. Dynamic application security testing is the set of tools which we are probably most familiar with when we think of security testing tools. And this is where a lot of your pen testers toolkit would normally sit. And essentially here we're acting as a client to a running application. And for that reason, they can be quite slow, but they're also generally quite accurate and revealing something that's true. Lastly, we've got runtime application self-protection. We're not using this yet, but it sounds really cool to me. But essentially you have that runtime application component again injected into your running application, and it's able to detect suspicious behavior at runtime and halt execution of that. So a good analogy might be a web application firewall, where your e-commerce application from the customer is receiving a request that holds a bunch of valid SQL inside it. That's almost certainly a bad thing to be running, so just drop it on the floor. But you can do this inside your application between like your view and your controller. Quite cool. Okay, now we're going to try and do a live demo. So I've been spending my weekends building a security tool, and we've been having some success with that at Cache Converters for getting visibility of our entire environment. And if I can find out which monitor I'm on over here. So hopefully you're all familiar with DevOps Dream, the game. Big shout out to Mechanical Rock for being brave enough to be scanned on the big screen. So this tool here is essentially a dynamic application security testing tool. And it works by feeding in a domain name. And it attempts to discover the related subdomains. And then once it's enumerated them, run some pretty simple low-impact probes on them. And here we go. Great, so we can see there's 3 related hosts to DevOps.games. Conveniently, and well done, Tim, there's no vulnerabilities that we're finding here. We can see there is a test environment available, which seems to be public. Potentially we can get access to some preview features here before they're released. But what I'd like to demonstrate next is that comment earlier about the complexity of your environment, reflecting how hard it is to secure. Tenable is a vendor we use at Cashies quite happily, and they are a leader in security solutions according to their website and Forrester. But they have more stuff, right? And it's easier then for more stuff to slip through the cracks. And this one will take a bit longer because there's more stuff to discover. But ultimately, it uses certificate transparency, if anyone's familiar, to discover hosts. I'm happy to talk more about this later. It's very cool and very fun. Right, so now we can see a lot more infrastructure and some red circles as well. So this particular host here actually has an expired TLS certificate. Something to do with their logins, not really sure what it's for. Further down, we have a host that, although it's got a valid certificate, it's also available without TLS. So if we have a look at that one, sure enough, it works fine, but if we try and access it without HTTPS, yeah, the site's still available. And remembering our hubris here, each of these are teaching moments, right? So if their engineering team needs more information on what this is, there's some documentation here describing how it can be exploited and how to fix it. And there's a few more down the bottom here. Here's another one where it looks like they're using Pingdom. It's like an application uptime monitoring service, but the CNAME and the certificates do not match at all. So I hope there was something useful for everyone there today. That DevSec Tools service is in public preview right now, so I encourage you all to check it out. I haven't load tested it yet, so if you could all do it in the next 10 minutes, that would be super. If you have any questions, please hit me up afterwards. Thank you.